Hi, Honors Algebra 2 students. We're in Chapter 8, Day 5 Notes, which focuses on solving radical equations. All right, so our instructions say solve the following equations, and if you look, we've got cube root equations to solve and square root equations to solve. All right, so our first example is a cube root equation to solve. So whether it's a cube root equation or whether it's a square root equation that we're solving, and we'll work with both in this lesson, we want to isolate the radical on one side of the equation. Well, if you look, our cube root is already isolated on one side of the equation, so now we can move on to the next step. All right, so the next step is to make sure that we can get to whatever is underneath the radical. So how are we going to do that in this case? Well, if we want to get to the x minus 2 that's under the cube root, we would need to cube both sides of the equation. All right, so what's that going to look like? All right, well, if I rewrite my equation down here, and then if I cube both sides of the equation, and we know what we do to one side of the equation, we have to do to the other side of the equation. Well, obviously, cubing a cube root will get us to whatever is underneath that radical. So in this case, x minus 2, and that's going to be equal to 8. And then finally, if I solve, I will get that x is equal to 10. All right, so the thing you need to know about solving radical equations is that this process of cubing both sides of the equation, or if it were a square root equation, the squaring process of both sides of the equation, that can introduce what are called extraneous solutions or extra solutions. So we need to check this answer and see if it works in the original equation. So let's do that now. All right, so if we go to the original equation and we plug in our 10 for x, let's go through and see if that works in the original equation. Well, obviously we would have the cube root of 8. The cube root of 8 is 2. So 2 is equal to 2. That's a true statement. So our answer of x equaling 10 does work. All right, so already you may be wondering, do I have to show the work for this check? All right, well, I would tell you to ask your teacher. What I require is that students do check their answers to see if they work. I don't require that they write it out, but I do tell them that if they're not checking their answers, that they are at times going to end up with extraneous solutions that they need to toss out and not keep as a final solution. And if you're not checking your answers when you solve for x, if you're not checking them back in the original equation, you will lose sight of if you have any extraneous solutions. So you do need to be checking them. Whether your teacher requires you to write out the check or not, you need to verify that with your teacher. The other thing is that I will say in this particular case, I will allow my students just to plug the 10 into the original equation and check their answer with just mental math. So, 10 minus 2 is 8. The cube root of 8 is 2. 2 equals 2. In other words, you can tell right away with just a quick mental math check that x equals 10 does work. All right, so our next example is solving a square root equation. And if you notice, we have two terms that have a square root in them. So we need to isolate the radicals. So in this particular case, we're going to isolate one radical on one side of the equation and the other radical on the other side of the equation. So we can either, move this particular term to the other side of the equation, or we can move this one to the other side of the equation. I'm going to move this second term by adding a square root of 3x minus 10 to both sides of the equation. All right, so if I do that, I'm going to get the square root of x plus 14 is equal to the square root of 3x minus 10. Now that each square root is isolated, one on either side of the equation, now I can get to what's underneath that radical by squaring both sides of the equation. All right, so when I do that squaring to each side of the equation, on the left-hand side, I'm going to have an x plus 14. In other words, squaring the square root leaves me with what's underneath that radical, so it would be x plus 14, and that's going to be equal to 3x minus 10. All right, then I have a linear equation to solve, so I would have 2x is equal to 24, so x is going to be equal to 12. All right, so then if I do that check as I was talking about before, and sometimes I will even do part of it mentally and then write part of it down. So here's what I mean by that. I could take this 12 and I could plug it in here, and I would have the square root of 12 plus 14, which would obviously be the square root of 26. And then I subtract from that. If I plug in a 12 right here, I'm going to have 36 minus 10, which is obviously the square root of 26 also. If I subtract those, I get 0. So again, this is one that you may be able to easily do just with mental math. You may write out kind of an intermediate amount of work. You may write out more work than I did. You may just do it all with mental math. But either way, make sure you check those answers to see if they indeed work in the original equation. And in this case, 12 does work, so 12 will be my solution. In our next example, we have another radical equation that involves a square root. So we first need to isolate that square root, and notice we only have one term that has a square root in it. So I'm going to subtract the x, so I'll have 3 minus x is equal to the square root of x minus 1. So I now have my radical isolated. So now in this case, I'm going to square both sides of the equation since I have a square root. To undo that, I'm going to square both sides of the equation, and if I do that, I get the following. Remember right here that you have a binomial that you are squaring, so make sure you FOIL that out. But we're going to get 9 minus 6x plus x squared is equal to x minus 1. And then notice that we have a quadratic, so let's get everything on one side of the equation so that we can continue the solving process. So we would get x squared minus 7x plus 10 is equal to 0. And then if we continue solving this, this will factor into x minus 5 times x minus 2. If I solve for that, I'm going to get that x is equal to positive 5 and x is equal to positive 2. All right, now let's write out the check for this particular problem and see if 5 and 2 work. So we go back to the original equation. Make sure you go back to the original equation and not the part where you squared it, okay? Because here's the thing, these two potential solutions came from your squared equation. So don't go back and check them in that version of the equation or that step, because obviously they're going to work in that particular step. That's what produced those answers. So we need to go back to the original equation to check these potential answers of 5 and 2. So let's do that now. All right, so if we check the answer of x equaling 5 first, we would have 3 equals 5 plus, and then again, the square root of 5 minus 1 is going to be 4. This is where I kind of combine doing mental math and still writing out some steps. So I get that 3 is equal to 7. Well, obviously that's not going to work. So x equaling 5 is not going to be a solution. So then if I now try 2 and I plug that in for x, and again, sometimes I'll do a little mental math along the way. 2 minus 1 is obviously going to be 1. The square root of 1 is 1. Well, 3 does equal 3. So that checks out. So x equals 2 will be my solution. I think this example shows the importance of checking these potential solutions and seeing if any of them are extraneous, because obviously in this case, one of them worked and one of them did not. Again, you will need to check with your teacher to find out how much work they require you to write down when you are checking your answers. All right, our next example is another solving of a square root equation. And if you notice, I've got 3 terms that have a square root in them. So I've got a square root of x, I've got a square root of 7, and then I've got a square root of x plus 7. So obviously I only have 2 sides of the equation. I can't isolate each one of those radicals on their own side of the equation. I've got 3 radicals and I only have 2 sides of the equation. So in this particular case, I'm just going to go ahead and square the left-hand side as is, and I'll square the right-hand side as is also. All right, so we're going to take the left-hand side of the equation and the right-hand side of the equation, and we're going to do our squaring. So we'll square the left-hand side, we'll square the right-hand side. Now if you notice, the left-hand side is a binomial squared. So it might not be a bad idea to write it out as such. May help us a little bit with our foiling. So obviously the squaring, you know, the square root of x minus the square root of 7, we could write out as such. That's a binomial squared. And again, that may help us with the whole foiling process. The right-hand side obviously is just going to be x plus 7. Okay, so if we now go through and FOIL the left-hand side of the equation, here's what we're going to get. We're going to take the square root of x times the square root of x for our first terms, and that will simply be x. Then if we take our outside terms, we would have the square root of x times a negative square root of 7. We're going to get minus the square root of 7x. And then if we do the same thing for the inside terms, we have a negative square root of 7 times the square root of x. That will give us another negative the square root of 7x. And then finally for our last terms, if we take a negative square root of 7 times a negative square root of 7, we're going to get plus 7. All right, right-hand side of the equation stays the same. All right, so if we simplify the left-hand side a little bit, we will get x minus 2 times the square root of 7x plus 7 is equal to x plus 7. And then if you notice, we still have a radical in our equation right here. So we went through the squaring process and we did it correctly, but we still have a radical at this point in our equation. So what that means is we now need to take this radical term, and we only have one term that has a radical in it, but we need to isolate that on one side of the equation and move everything else to the other side of the equation because we need to go through this squaring process again. So let's see what that looks like when we do that. Well, in this particular case, if I move everything else to the other side of the equation, I'm actually going to get that negative 2 times the square root of 7x is equal to 0. And here's the reason for that. Obviously, the x's cancel out. The 7's also cancel out. So again, in this particular case, when I isolate my square root term on one side of the equation and everything else on the other, it just so happens that it's equal to 0. It won't always be, but in this particular case it is. All right, so let's do one more thing before we square both sides of the equation again. Let's go through and truly isolate this radical term. So let's divide both sides of the equation by negative 2, and as such, we would get the square root of 7x is equal to 0. All right, so now that our radical term is completely isolated, let's go through and square both sides of the equation again. And when we do so, the left-hand side will simply be 7x, and the right-hand side is going to be equal to 0, obviously. So in this particular case, when we solve, x is going to be equal to 0. All right, so let's go through now and check out our potential solution of x equaling 0. So if we plug in 0 for x on both sides of the original equation, we would get the square root of 0, which is obviously 0, minus the square root of 7. Is that going to be equal to, if we plug a 0 in for x on the right-hand side and simplify the radical, we would get the square root of 7. So negative square root of 7 is not going to be equal to a positive square root of 7. Obviously that does not work. So in this particular case, our x equaling 0 is not going to work. So our final answer is going to be no solution. Or if you want to use the mathematical symbol for no solution, you may. All right, in our last example, you'll notice we have another square root equation to solve. You may also notice that we have two terms that have a square root in them. So let's put one square root term on one side of the equation and move the other square root term to the other side of the equation. Doesn't matter which one you move, I'll move the second one here. All right, so if we do that, it would look like as follows. All right, so now that we have one square root term on one side of the equation and the other square root term on the other side of the equation, now we'll square both sides of the equation. The left-hand side will simply be x plus 3. Now the right-hand side, again, is a binomial squared, so wouldn't be the worst idea in the world to write it out like I am writing it out. Side by side, I think that can help with the foiling process. Left-hand side will still be x plus 3. All right, the right-hand side, when we FOIL this, the first terms will be 9. The outside terms will give us negative 3 times the square root of x minus 3. The inside terms will give us another negative 3 times the square root of x minus 3. And then the last terms will give us plus x minus 3. Now, you may need to pause the video and make sure you get that written down, as well as make sure that you understand why the answer is from the foiling step, you see written right here. But again, just to summarize, 3 times 3 for the outside terms will give us 9. 3 times negative the square root of x minus 3 will give us just that, negative 3 times the square root of x minus 3. The inside terms will give us, in this particular case, the same thing. And then the outside terms, when we take a negative square root of x minus 3 times a negative square root of x minus 3, negative times a negative will give us a positive, and then we'll get what's underneath the radical, which is simply x minus 3. All right, so now you may notice that our squaring process up here still left us with some radical terms. So we're going to need to isolate these radical terms on one side of the equation and move everything else to the other side. So let's take a look at what that would look like. All right, well, our x terms would go away. And then if we take what we have on the right-hand side, 9 minus 3, this 9 minus 3 over here on the right-hand side would give us 6. If we subtract 6 from both sides of the equation, we're going to get negative 3. And then that will leave us on the right-hand side, if we combine these two radical terms, a negative 3 times the square root of x minus 3, minus 3 times the square root of x minus 3. If we simplify that, that will be negative 6 times the square root of x minus 3. All right, so we have our radical term isolated and everything else on the other side. Now here's where you have some options. You could divide both sides of the equation by negative 6 and get 1/2 over here is equal to the square root of x minus 3, and then square both sides of the equation. You could do that. Or you could go ahead and square both sides of the equation right now. If you don't want to work with the fraction, that's fine. You could square both sides of the equation right now because you have isolated this radical term. So you could square both sides of the equation right now. Or sometimes students will do kind of somewhere in the middle. You know, they might divide both sides of the equation by a negative 3, for instance, and then square both sides of the equation. Any of those options are fine. But I think instead of working with the fractions, instead of dividing both sides of the equation by negative 6 and then having a half over here, and then squaring both sides of the equation, I think I might avoid the fractions and just square both sides of the equation right here. But I want you to know you've got options, okay? You definitely have options. All right, so let's say I go with squaring both sides of the equation right here because I truly have isolated the radical, so I could certainly do that at this point. All right, well, the left-hand side would be a positive 9. The right-hand side, don't forget that we need to square this negative 6. All right, so that's going to be a 36 when we do that. And then if we square this square root, we're going to get that that is x minus 3. So notice how I've written this, though. Be careful that you notice how I've written that because we're going to have to end up now distributing the 36. So 36x minus 108. Notice we have a linear equation to solve. So if I get my variable term on one side of the equation and I get my constants on the other, I'm going to get 117 is equal to 36x. And if I go through and I simplify that and solve, I'm going to get that x is equal to 13/4. All right, now you may need to pause the video and make sure that you follow the squaring process right here. You follow the simplifying the linear equation that results from that. Make sure you can get down to understanding that x is going to be equal to 13/4. All right, so you may be thinking already, do I have to check this answer and do I have to check it without a calculator? The answer to both of those is yes, you need to have the ability to do that. So I'm going to move over here to the right hand side and actually show the checking of plugging an x value of 13/4 into this radical equation at the beginning, our original radical equation. I'm going to show you what that looks like. All right, so I obviously had to reposition the slide within the video so that I could show the work for this potential solution. So right here you see the original problem, and then here you see our potential solution that we're going to go through and check. So what we're going to do is we're going to take this value of x equaling 13/4 and we're going to plug it in for each occurrence of x and then see if it works. All right, so when I do that on the first radical, I'm going to have the square root of 13/4. And then maybe I go ahead and I change that 3 to 12/4. And then I'm going to plug in the 13/4 in the second radical for x. And then maybe I go ahead and change that -3 to -12/4. In other words, find a common denominator right away. Then if I simplify my first radical, I'm going to get 25/4. If I simplify my second radical, I'm going to get 1/4, and again that just comes from 13/4 plus 12/4 gives me 25/4. 13/4 minus 12/4 gives me 1/4. Right hand side is obviously 3. All right, well, the square root of 25/4 is just going to be 5/2 because the square root of 25 is 5, the square root of 4 is 2. So that will give me 5/2. The square root of 1/4 is going to be 1/2 because again the square root of 1 is 1, the square root of 4 is 2. Well, 5/2 plus 1/2 gives me 6/2, and that is obviously equal to 3. So in this case that obviously checks out. So our answer of x equaling 13/4 does work in the original equation, so it will be our solution. All right, so in this particular case of checking our final answer, I want you to realize that yes, you do need to have the ability to check all of your answers without a calculator. And how much work you show, this one, you're probably going to have to show a little bit more work in doing the check. If you're doing it without a calculator, you're probably going to need to show more work. So again, check with your teacher to know how much work they require you to write down. But regardless of that, even if, they let you do some of the checks mentally, in this particular case, you're probably going to need to write down some work along the way to check that final answer. All right, so this lesson has shown you how to solve both square root equations and cube root equations and different scenarios within that. In some cases, we had only one radical in our equation. In other situations, we had more than one radical in our equation. So it showed you how to go through the process of doing that. It also showed you what to do if you go through that squaring process, for example, and you still have a radical in your equation. You need to go through that squaring process again. And then it also emphasized the importance of checking your answers to see if they work in the original equation, because you can have extraneous solutions. So you do need to go through and do that check to see what your final answers will end up being. All right, so this is the end of the Day 5 notes for Chapter 8.